All right, BC 2021 AP Calc free response number each knee bond. All right, here we go. It is a parametrics. I'm going to have it right here, you guys. I'm going to go on to a blank screen. So I have kind of a fresh page so you can pull it up and work with me. All right, here we go. All right, so first question. Find the speed of a particle at time t equals 1.2. Find the acceleration vector of the particle at time t equals 1.2. So we all know for speed, that is simply the square root of your position or your velocity, okay, squared, plus your y squared. Oh, I guess square the whole thing, right, you guys? And that would be approximately equal to 1.271. So here you just had to be careful that in this problem, they give you the velocity vector. Okay, so this is really just the v, x of 1.2 squared plus the v of y of 1.2 squared. Okay, and then for the acceleration vector, you just have to take the derivative of velocity, which happens to be the second derivative of position. Okay, and if you do that correctly, you get your velocity vector of 6.247 and 0.405. All right, so that's all it was, you guys, for the first part. Let's go ahead and look at part B here. I've got it over here to my side as well. Part B just asks to find the total distance. So I can just add it here to the bottom, then I will erase. Find the total distance. Well, for total distance, once again, right, I begged you guys to have these little formulas memorized. Once again, it is your velocity squared of your x component and your y component, and you should get 1.010. So hopefully those answers look super duper familiar. All right, now that was awfully nice. Now I would beg to say that the first part was probably worth I would say 3 points, and then the second piece I would say would be worth maybe 2 points. So with that being said, part C must be worth like maybe 4 points. Could have maybe even been 5 points. So let's go ahead and see what part C says. Find the coordinates of the point at which the particle is farthest to the left. Explain why there is no point at which the particle is farthest to the right. Okay, so now in order to do this, all I really truly care about right now is dx dt, where the position is from the x coordinate. So we're going to go ahead and find dx dt, which remember, they give us the velocity to start out. And I'm going to set it equal to 0, right? I'm going to find the critical points. Now, if you do that and you graph, you notice that it is equal to 0 at time t equals 1. Okay? Now, we need to find out where this position is at that point in time. So we're going to find x of 1. Now, x of 1 is going to be equal to x of 0 plus the displacement from 0 to 1. Okay? And we get that. Now, if you plug in all that stuff into your calculator, we get that is approximately equal to negative 2.064. Now, let's go ahead and find the y position for this guy in case we maybe need it for a little bit. Okay, but once again, that would be the initial position of y at time t equals 0, and then the displacement, which would just be the antiderivative of velocity, which that's at 5.410. Now, the interesting thing here is we do a sign analysis here for my dx dt, or for velocity, right, of this guy. We notice that it equals 0 at time t equals 1. Okay, and it changes from going from negative to positive at that value. Therefore, we know that x of t has a relative minimum, right? It's going to decrease and then increase in terms of the x position. Okay, that's going to be a relative min at time t equals 1. Since there's only one critical point, right? And then after time t equals 1, it's just going to keep on going to the right. And it's just going to keep on going to the right forever and ever and ever, right? So there's no point where it ever gets to the furthest to the right, because it just keeps on going. And it says right here in the directions for t greater than or equal to 0. So it does get to the farthest to the left, and it's farthest to the left at negative 2.604, comma 5.410. And then after that, that dude just keeps on chilling to the right. He's like, yo, I want to get out of town, right? That's exactly what he's saying right there. And that is why we would say that it doesn't go any further. And I can't even think of anything else you would need to tell the AP graders in that standpoint, other than then you do want to write that out. Okay, that dx dt is always greater than 0 after time t equals 1. And that, you guys, that is it. That is done. So that is question 2 done. How about that? I'll see you in a moment, and we'll work on the next BC question.